So this is the amplification part, and it seems to kind of work here, but I'm not so sure. So first things, I'm not so sure if that is something that depends on the way you flag. So this means that this amplification depends on the way you flag, or those two things are independent completely. Um, because it seems to play with Hadamard X gates in you know in a way that and then another Hadamard. So in, I'm assuming this is what's going here is again. So you're creating uncertainty by using the Hadamard gates, and then you're flipping bits here and there, um, in such a way that you're gonna amplify the particular state that you want. And I think that that probably works only because of the way this is being flagged, right? This means your starting point is already in a certain way, so you already have the stuff that you want with a positive amplitude, and the stuff you don't want with a negative one. So all you have to do is you have to basically cancel the other ones. But I don't know if that's sort of the generic implementation, or this is the case for or this is a case for the for that particular input. You know what I mean? Um, because if so if what we're doing here is, what if we change that? What if I wanna flag this 1 0? Now the question is this the one? Is this the one that this is the one that we're flagging 1 0? Let me remove everything. 1 0. Yeah. Yeah, but now it's like we flagged it negative and everything else is positive. And if we do this, okay. And if we do this, this is 0 1. And if we do this, it's 1 1. And so because maybe there's no way to flag the 0 0 other than just flagging everything else. That may be the reason why this is in this case. But let's try a different example. Let's stay like that. So we're now flagging 1 0. So we want to cancel those other. So cancel. We want to reduce those the other. Um, because what's happening is, so, and again I'm just sticking because of this is being, so here you know that since there are only two solutions and 8 possibilities, we will only need to run this operation, this thing once. But for a bigger amount of qubits, you probably need to run this like twice, or 3 times or 4 times. And so I'm sticking to this here, and this as well. I'm trying to see kind of, so if this is what we're having, right, when we now add Hadamards, what happens? So when we now add Hadamards, we're not there yet. So we're not Hadamards, and then there are two X operations, because this feels like it takes us to the same spot. It takes us exactly to the same spot, right? It takes us exactly to the same spot, and then if we were like that, that's a bit of a different one. 1 0 0 0 0 1. it seems like it's taking us to the same spot. I mean, this is the state you have, which is all like 0 0.5, 0 0.5, 0 0.5, and this is like a -1, right? And if I just remove all this, I bet you we're at the same spot. Yeah. But it's because, again, this is sort of the part of the algorithm that maybe reflects that when you repeat that again. Um, because what it basically does is it creates, so this would be the part that you repeat. So from here, like before that, it's just the input, and then this is what you repeat over and over again. I'm not so sure if this is what I'm. No. Ah, I guess because here they consider that, so they consider that as being part of the flagging. Okay, so they consider this being part of the flagging, and maybe that's okay. Okay, I think I know. Okay. Yeah, maybe that's just like this. That's just the way you flag it. This is just to get into superposition. This is the first step. This is flagging what you want, because at the end of, because you see it makes it's easy, it's difficult to get confused by these. So if I basically say, and that Z kind of tells you what we're trying to do. So now we have 0 0 because there's no Z's. Okay, so it kind of I know. So it kind of corrects what we said, because before that it was like, oh, if you don't have those gates here, then for the 0 0 case where you want to flag the 0 0 case, well, you cannot. So you basically, when you do that, you actually have everything else flagged. Okay, so those two Hadamards, those Hadamards here, and this axis, they basically correct that. So I mean, okay, so in a way that now basically by changing those gates, you can define what you're flagging. So if you have two Zs, you're flagging 1 1. If you have, like, this is 1 0, obviously this is 0 1, and when you have nothing is 0 0. So that's how you flag. Cool. And I think that's definitely something that we can then extract as a separate sort of intuition device. How do you flag how do you flag in a one state in a superposition? And maybe that is extendable, to other qubits even. So if I say, I'm going on a tangent, but let me check. If I do that, and but I'm gonna need I'm gonna need like a control Z here that I cannot. I have to figure out how to do that. Maybe there's a better way, but I'm assuming that extends easily to multiple qubits. Perfect. Let's go back to the algorithm. So this is what we have. So this is the flagging part. Good. And then what happens is, so then you get into that other portion here, where you have this. So and I think it's easier if we put here, like if we would move this and this a little bit like that, because it's gonna be easier to understand. But what's happening basically, I'm trying to understand what happens, sort of block by block, because now what's the next step is, so now we have the stuff flagged in here. So the next step is a Hadamard, a control knot, and a Hadamard. What? So we're back at this. But the information is definitely somewhere else, right? Because now the algorithm goes ahead and does like XX. So I'm just gonna add an identity here to make it more readable. But if now I say XX, what's gonna happen? XX. Hadamard, Hadamard, 0, 0. And that's it. Because here essentially it says then you run that and that's it. So and that's kind of the simulator. It's like, so you find the stuff that you flagged. And so if you would flag 1, 0, or you would flag 0, 1, or you would flag 1, 1. So that's what you're finding here, so to say. Interesting. But why does this happen? So up until this point, let me just remove this. Up until this point, I kind of understand what's going on. But so this thing now with the Hadamard control node and Hadamard, this is what's interesting. Because what if I do that? Does it change anything? Does it change anything? No, it's just, and now it's going to be like that. So in the case of like we're flagging like 1, 0, right? I think you can't really, maybe you can't just really understand that at that low level. So you have to understand the entire operator, as in kind of what's happening here really. Because at the end of the day, what's happening here is, and so now we have the element that we want. So up until that point, we have the element that we want flagged. Up until that point, exactly. And then maybe I'm seeing this wrong. Maybe this is indeed up until this point that you have the element you want to flag, because remember 0, 0, 1, 1. And so what this first bit is doing here, so what this, I mean, intuitively, this is intuitively playing with the signs, right? That's what it's doing. I just, it's pretty amazing how someone can just come up with that. I guess they do that at the mathematical level, and then they just abstracted it to a circuit. Because the Hadamards will then kind of create those different positive and negative uncertainty states, and the X will just flip the signs. Okay. Curious about the control knot. Why the control knot is here? Anyhow relevant. Put the pieces together with the creation of uniform superposition. So here's the circuit of the inversion. So they call it inversion. Controls. So I understand the geometrical explanations, but I think they might be a little bit off. Or it doesn't help me to intuitively understand why this is having the effect it's having. So yeah, so just trying to think. I'm just trying to think. Just trying to think. Get a maybe. Can I just get a new circuit somewhere? New, without losing this one, hopefully. I don't want the colors, and I want to stay back to, because essentially, right, when we do that, this is superposition. And so when we're doing these X and X, right, really, it seems like, I mean, nothing happened. Density matrix. Nothing happened really because nothing happened exactly. I know. Okay. So nothing happened because we're coming from 0, 0, right? As soon as here we have, or the other way around, as soon as here we have something, as soon as here we have something that is a 1, right? Then this starts to behave interestingly, because then you're flagging things. Exactly. Then it's not you're flagging things, you're moving the sign around at the end of the day, right? So that's the interesting part. So, and because, and so what's happening here is, what's happening here is in the first portion, right? Okay, so in the first portion here, basically, because you're flagging, up until here, you're flagging basically with a -1, the state that you want to, that's the one you want to find, right? And then that extra step here with the Hadamard, it's basically kind of, that's cool. So basically, for a second, it basically turns all the stuff that that is positively kind of back into 0, and then the stuff that's negative back into 1, because that's the effect of the Hadamard. So that's kind of destroying in this sense. And so if I am here and I basically let's clean that up. So if I'm here and I'm just saying, we've got that, and then we're flagging this 0, this here, then we're doing a Control Z. Sorry, we're moving the X here, right? So back. So we're kind of like reconstructing this. So we're now here. So you have this flagged, and because of that, when we now apply the Hadamards, what has happened here is, because really, that's so the flagged atom has flipped now. So, and when we now do the XX, so we're back at this place. I don't quite understand. I don't quite understand sort of what the inner workings exactly are. But maybe that's it's just too deep. That's not, maybe, you know. Um, I'm getting lost because of that, and trying to understand piece by piece if they can find sort of what's really happening under the hood. Maybe that helps me kind of feed back into some interesting intuitive bites for you guys. Because so I'm trying to understand what is the effect of those things. So what is the effect of something like that, for example, right? Say so if I'm going to clear this one, no, because I don't like clearing, because then it goes back to it gives me back to 5 qubits. So so what is the effect of something like that, right? So if I have 0, 0, then it's of course like a 0, 0. Okay, 1, 1. if I'm coming from like a superposition, from superposition, and 0 1 0 0. So if I'm flagging 1 0, because it seems to kind of do stuff, then whatever, and then undo, right? So it's kind of like, but then at the same time, the idea of this algorithm is that what you repeat is that part, so including this portion here, which is the flagging. Yeah, it's interesting. It's interesting. Damn it, damn it, damn it. So why is that supposed to be? Apply an additional reflection about the state as this transformation maps the state to the complex transformation. So geometrically, I understand, but it just doesn't help me. Mm. Hmm. I understand the flagging, but I don't quite understand how does the amplitude amplification kind of works in a more general setup. Because that's this part, this part here, right? So it's this part here, and now in our case it's kind of restricted to that. Yeah, I'm gonna have to give it another try, I guess. It's tougher than I expected. Why does this intuitively work? Because I'm sure if you make the maths, then you're gonna get to the conclusion that what this is doing is basically, yeah, you're adding and canceling states, possible states. So at the end of the day, you have whatever you want. So I get that, but it's it doesn't feel enough. It doesn't feel enough for me. To me, it doesn't feel enough.